Last lecture we have completed what is ionic bond. So ionic bond is the Coulombic force of attraction between the oppositely charged ions. Means electrostatic force of attraction between the oppositely charged ions. Means ionic bond. So ionic bond is, it is electrostatic force of attraction ionic bond is electrostatic force of attraction between oppositely charged ions. It is called electrostatic or Coulombic force of attraction between cation and anion. So now we will discuss factors influencing the formation of ionic bond. Factors. So there are factors which influence the formation of ionic bond. So first factor is ionization enthalpy. It is the amount of energy required to remove an electron from an isolated gaseous atom. Means energy required to form cation actually. Energy required to remove an electron from an isolated gaseous atom. That means if energy required to remove the electron is less, then cation can be easily formed, because to form an ionic bond we need a cation as well as an ion, and the attraction between them is the ionic bond, right? So first and foremost thing is we should have cation and anion. So if cation is formed easily, the chances for the formation of ionic bond is more. First factor is lesser is the ionization enthalpy, more is easily cation is formed. More easily cation is formed. So cation formation is easier if energy required to remove the electron is less. So tell me which metals, obviously cation is formed by metals, because metal has greater tendency to lose electrons. And what about non-metals? They have a tendency to gain electrons. So obviously the cation formation is easier for metals. So tell me which metals can form cation most easily. Group 1 elements, because along the period ionization enthalpy increases. So the elements present to the left have greater tendency to form cation because their ionization enthalpy is lowest. Alkali metals and alkaline earth metals, group 1 and group 2, alkali metals and alkaline earth metals form cation because they have lowest ionization enthalpy in the periodic table. Means these are alkali metals and alkaline earth metals are combinedly known as S block elements. So S block elements जो है they can form cation easily. That means they can form ionic bond easily because they have low ionization enthalpy. So favorable factor as that of ionization enthalpy with regard to ionization enthalpy, low ionization enthalpy is in favor of ionic bond formation. So low ionization enthalpy of the element and particularly metal. Okay. Now second factor. Second factor is electron gain enthalpy. Electron gain enthalpy, that is electron gain enthalpy. So electron gain enthalpy, as the name suggests, it is electron gain. That means amount of enthalpy change when an electron is added to an isolated gaseous atom. Say if we have B atom in the gaseous state and after gaining electron it forms anion. So how much energy change takes place, that is called electron gain enthalpy. So when electron is added, say when electron is removed, that is for ionization, there is a work against attractive force between the electron which is to be removed and the nucleus. There is an attraction between the electron and the nucleus. So to remove it, we have to provide energy. But when electron is added, so it should be attracted by the nucleus. This extra electron from the outside, if it is added to the atom, it is attracted by the nucleus. So when there is an attraction between the nucleus and the added electron, there should be a release of energy. Energy should be released. Okay, and if energy is released, say energy absorbed has sign convention positive sign. Okay, for energy released, it has a negative sign. Okay, so electron gain enthalpy should be negative. First of all, first and foremost condition is when electron is added to an isolated gaseous atom, electron gain enthalpy should be negative. And higher the negative value of electron gain enthalpy, more easily anion is formed. Like lower ionization enthalpy, then more easily cation is formed, and higher the negative value of electron gain enthalpy, more easily anion is formed. So in favor of anion formation is the higher negative value of electron gain enthalpy. So electron gain enthalpy should be high. Negative sign only indicates that energy is released. Okay, that is in the most of the atoms, when electron is added, energy is released, except in noble gases or fully filled configurations. Okay, when electron is added in noble gases, you know, they are already stable, so they become unstable, so their energy is increased, means they absorb energy, so their electron gain enthalpy is positive. That's why they cannot form anion. Okay, so anion is formed easily by those atoms having higher negative value of electron gain enthalpy. So this is the second factor. First factor is ionization enthalpy should be low, electron gain enthalpy should be more negative. So second factor, which is in favor of ionic bond formation, is high negative value of high negative value of electron gain enthalpy. Low ionization enthalpy and high negative value of electron gain enthalpy. So if ionization enthalpy of metal, right, is low, cation is formed. If high negative value of electron gain enthalpy is for non-metal, anion is formed. Now we get cation and anion. Now third is lattice enthalpy or lattice energy. Do you know what is lattice? Lattice means arrangement of, it is three-dimensional arrangement of particles. 3D arrangement of particles. For example, if a wall is formed, we have to arrange bricks to form a wall. To form a wall, what we do? We arrange the bricks in 3D, right? So that is one type of lattice. Okay, so three-dimensional arrangement of particles like atoms, molecules or ions, right? So that is called lattice. Okay, now in ionic bonds there is arrangement of cation and anion, right? So lattice enthalpy with regard to ionic bonding. So what is the definition? The energy released. So this 3D arrangement give rise to formation of a solid. Okay, so lattice energy is amount of energy released when 1 mole of crystalline solid is formed by the combination of oppositely charged ions. Okay, cation, anion. I will write one lattice of NaCl, then you will come to know how the lattice looks like. Okay, but anyhow, what is lattice enthalpy? Amount of energy released when 1 mole of crystalline solid. Crystalline means regular arrangement. Okay, crystalline means when there is a regular arrangement, like, you know, in the morning there is a prayer in the school. So during prayer, or we can say during national anthem, everybody is standing in a straight line. Okay, so those straight lines in the school, that means that shows the arrangement of the assembly. Okay, so that type of arrangement is called crystalline, and its opposite is amorphous, recess time. Recess time, everybody is in the random state, everybody is moving here and there are different groups. Okay, so there is randomness in the arrangement. That random arrangement is amorphous. Crystalline, opposite of crystalline is amorphous. Amorphous means random arrangement. And crystalline means regular arrangement. Okay, uniform arrangement. Okay. Okay, so amount of energy released when 1 mole of crystalline solid is formed by the combination of oppositely charged ions, because when there are oppositely charged ions near a neighboring, in the neighborhood, what happened? There is a force of attraction, and whenever there is a force of attraction, energy is released. Okay, so how much energy is released, that depends on the attractions. More are the attractions, more is the energy released, and more is the lattice enthalpy, and higher is the lattice enthalpy, higher are the chances for the formation of ionic bond. Got it? So higher the lattice enthalpy, that means it can be represented as A plus gas plus B negative gas to give AB solid. This is crystalline solid. These are gaseous ions. When they are arranged in 3D, we get ionic solid, and energy released here is called lattice enthalpy. So actually lattice enthalpy is the amount of energy released. That's why higher is the lattice energy or enthalpy, higher the lattice enthalpy, more is the attraction between oppositely charged ions. More is the attraction between oppositely charged ions, and greater is the stability of ionic bond. Okay, so that means if we say the factors which influence the formation of ionic bond, first is low ionization enthalpy, second is higher, or we can say high negative value of electron gain enthalpy, and third is high lattice energy. Right? So these are the factors which influence the formation of ionic bond. If lattice enthalpy plus negative value of electron gain enthalpy is greater than ionization enthalpy, then ionic bond is formed. Okay, and if lattice enthalpy plus negative value of electron gain enthalpy is less than ionization enthalpy, then ionic bond is not formed. That's it. Inner characteristics of ionic compounds. Okay, so let us take a case of NaCl. Okay, now NaCl, to have NaCl 1 mole, we need 1 mole of Na plus and 1 mole of Cl negative. They are arranged in 3D. Say like this. NaCl has cubic structure. Now I will make a cube. Is it visible? Yes. Say okay. So this is the cube. Okay. Now NaCl has cubic lattice. NaCl has cubic lattice. Now this lattice I will divide into 2 equal halves. These are 2 equal halves. Then from here 4 halves. Okay, it is, this cube is divided into 4 halves. Okay, then okay. Now tell me how many parts this cube has. How many small cubes this cube has? This bigger cube, I have divided it into small cubes. How many small cubes? 1, 2, 3, 4. This one is 1 cube. Okay. 1 cube, and then second cube, third, fourth, fifth, sixth, seventh, eighth. So there are 8 parts. Okay. Now let us start from here. Suppose this is Cl negative and this is Na plus. Okay, so if here it is Cl negative again Cl negative, Na plus, 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 Cl negative, again Na plus, Cl negative, Na plus, Cl negative, Na plus, Cl negative, again Na plus, Cl negative, Na plus, Cl negative, Na plus, Cl negative. Then, okay, Na plus, Cl negative, Cl negative, Na plus, done. So there are Na plus, Cl negative, Na plus means at alternate position there are Na plus, and each Na plus is surrounded by Cl negative, and each Cl negative is surrounded by Na plus. Okay, arrangement is called a lattice, and when in this type of arrangement 1 mole of cation, 1 mole of Na plus and 1 mole of Cl negative are arranged like this, Na plus gas and Cl negative gas, when they are arranged to form NaCl solid 1 mole, so energy released is called lattice energy. That energy is called lattice energy, and this arrangement is called a lattice. This is NaCl type lattice. Yes, so characteristics. So in ionic compounds, oppositely charged ions are arranged in 3D, and there is a strong electrostatic force of attraction. That's why, what is their physical state? Tell me, what is the physical state of ionic compounds? Very good. It is always solid. So, ions are arranged in 3D to form lattice, and there is strong forces of attraction. There are strong electrostatic force of attraction between oppositely charged ions. So they exist as solid. So they exist as solid. So first thing, physical state. So ionic compounds are always in solid state. Okay. Second, melting and boiling points. Melting and boiling point is always high because there are strong inter-ionic attraction. There are strong interionic attractions between oppositely charged ions. So they have high melting point as well as boiling point. Electrical conductivity. That is very important point. Electrical conductivity. Ionic compounds are bad conductor of electricity in solid state because there is no movement of ions in solid state, and ionic conductivity is due to the movement of ions. But in molten state or in aqueous solution, ions are free to move. So they are good conductor in molten state or aqueous solution. So you should write that in ionic compounds, electrical conductivity is due to movement of ions. First statement should be that electrical conductivity is due to movement of ions. So electrical conductivity is due to movement of ions, and they are bad conductor of electricity in solid state because ions are not free to move, because there is a strong electrostatic force of attraction. So ions are fixed in solid state, they are not free to move because there is no free movement of ions, or we can say there is no movement of ions in solid state. Got it? Good. Now let us talk about solubility. So this is the third characteristic of ionic compounds. Now solubility. Keep in mind, here we write like dissolves like. Like dissolves like. This is the formula of, this is the principle of solubility. Okay? Means polar compounds are soluble in polar solvents non-polar compounds are soluble in non-polar solvents. So actually ionic compounds they are extreme case of polarity. Say polarity means like we have HCl. In HCl, you know, Cl gets partial negative, hydrogen gets partial positive due to the difference in electronegativity. Cl is more electronegative, hydrogen is less electronegative. Like these are the poles, negative pole, positive pole. More electronegative means electrons shared pair is more attracted towards Cl. It is away from hydrogen and close to chlorine. Unsymmetrical distribution of electrons. Like if we have H and H, it is obviously non-polar. If we have Cl and Cl, bond pair remains in between these two. Bond pair remains between two chlorines. Bond pair remains between two hydrogens. So these are the non-polar bonds. But here it is polar bond. Okay? Or polar molecule. Now in case of ionic compound, you know, NaCl. So Na has complete positive, Cl has complete negative. That this is the extreme case of polarity. Ionic compounds are extreme case of polarity. That means polar compounds or ionic. Ionic or polar compounds are soluble in polar solvents. Okay. Polar solvents like H2O. In H2O, we have oxygen and two hydrogens. You know, oxygen has 6 valence electrons. Out of 6, you know, 2 are shared. So it is left with 2 lone pairs. Out of oxygen and hydrogen, which one is more electronegative? Obviously oxygen. So oxygen gets partial negative and hydrogen gets partial positive. So in this way, water is a polar solvent. Water is a polar solvent. Okay, but benzene, CCl4 are non-polar, or we can say organic, or non-polar solvents. So they are not soluble in non-polar solvents. Now say we have NaCl solid. So NaCl solid, when dissolved in water, we get Na plus aqueous plus Cl negative aqueous. NaCl solid, when dissolved in water, we get Na plus Aq. Aq means aqueous. Cl negative, Aq means aqueous. What it means actually? See, NaCl, when it is converted into Na plus aqueous, Na plus gas and Cl negative gas, up to this stage, it is called lattice energy. Means lattice energy is defined in 2 ways. First is amount of energy released when 1 mole of ionic solid is formed from its gaseous ions. From these ions, 1 mole of ionic solid is formed. This is called lattice energy, but definition is amount of energy released when 1 mole of ionic solid or 1 mole of crystalline solid is formed from its constituent gaseous ions, or amount of energy required to break 1 mole of ionic solid into its gaseous ions. energy is absorbed. Here energy is released, and here equal amount of energy is absorbed. So I can define lattice energy in second way, that is amount of energy required to break 1 mole of ionic solid into its gaseous ions, and vice versa. Okay, so this is lattice energy. Now these ions, when interact with water, we get Na plus aqueous, Cl negative aqueous. How it is formed? See, this is Na plus. So Na plus in water, it is like this: negative, positive. So Na plus, O negative is attracted towards Na plus. So it is like this. Water around Na plus. And what about Cl negative? Hydrogen is towards Cl negative. So this is called hydration. When water interact with cation and anion, this is called hydration. So amount of energy released, because Na plus and hydration enthalpy. This is called hydration enthalpy. Amount of energy released, amount of energy released when amount of energy released as a result of attraction between ions formed from 1 mole of ionic solid and water. Ions जो बने from 1 mole of ionic solid, when they interact with water, the energy released is called hydration energy. Say, here energy is absorbed, here energy is released. So, if hydration enthalpy is low, is high, or lattice energy is low, they favor the solubility of ionic compounds in water. That means hydration enthalpy should be high, lattice enthalpy should be low, then solubility is high. So ionic compounds actually they are soluble in water, but because hydration enthalpy is high. What is hydration? Water surrounding the ions, and because of this arrangement of water or water surrounding this ion, there is an attraction, and due to that attraction energy is released, and that energy released is called hydration energy. Okay, and most favorable factor is lattice energy should be less than hydration enthalpy, then solubility is high. Okay, so this is about solubility and hydration energy. So you got what is hydration? Yes, anybody who has doubt? हाँ बेटा, only 2 minutes more. Yes, less lattice energy and high hydration enthalpy, more soluble compound. Okay. Now last is ionic reactions. This is fifth point. So ionic reactions, say covalent compounds give molecular reactions, ionic compounds give ionic reactions. So keep in mind, ionic reactions are fast because there is only rearrangement of ions. There is no breaking or formation of bonds. Okay. For example, if we have AgNO3 along with NaCl, then we get AgCl solid plus NaNO3 aqueous. Actually, in this case, if we look at this reaction, AgNO3 aqueous means it is simply in the form of Ag plus and NO3 negative. Already it is in this form in the solution. NaCl aqueous means it is already in this form. So there is no need to break it. They are already in ionic state. Okay. So Ag plus will choose Cl negative and form AgCl solid, which is white PPT. You know AgNO3 is test for chloride ions. Okay, white PPT along with Na plus aqueous and NO3 negative aqueous. So, in nutshell, ionic characteristics are ionic compounds are solid. They have high melting and boiling point. They are bad conductor in the solid state, but very good conductor in molten or aqueous solution. Then they are soluble in polar solvents like water, and ionic reactions are fast. So these are characteristics of ionic compounds. I repeat once again, ionic compounds are solid, ionic compounds have high melting and boiling point. Ionic compounds are a good conductor in molten state or aqueous solution, but bad conductor in solid state. Then ionic compounds are soluble in polar solvents like water. Then ionic reactions are fast. That's all for the day. Thank you so much. हाँ रालम ठीक है.